Hi everyone, my name is King IV, and this is lesson 2 on natural language processing with Python and NLTK. And in today's lesson, we'll be covering accessing text corpora and lexica resources. And if you haven't checked out the source that I'm using, which is nltk.org, I recommend that you check those out if you're interested in learning more. So here I have a bunch of different libraries that I'm going to be, bunch of different modules I'm importing. But let's go down to this first area. So Gutenberg hosts a bunch of different text documents here. And what we're going to do here is we're going to list out the Gutenberg text and a bunch of different statistics on them. So things like average word length, average sentence length, and average occurrence of words. So here we're calculating the number of characters. We're just taking the Gutenberg.raw and going through each file. Same thing here with the number of words, the number of sentences, and the number of unique words. And then we're going to print that. So let's go ahead and take a look at that. So here, just importing some of the documents if you would have saw module 1, just because we're going to use that a little bit later. So now you're going to see here 5, 25, 26. This Austin-Emma, and it's going to list out a whole series of different ones. So this will help you better understand what kind of text and documents are you dealing with, what are some of the key statistics to help you observe some patterns. Perfect. So let's comment that section out. And let's comment the next section, which is going to be with the Brown corpus. And what we're going to do here is we're going to be tabulating the uses of words by type of text. So here we're just going to print out the various categories there are. We're going to print out the words are used in news, for example, and then we're going to run the statistics here, determine how many words are used for each one. And then we're going to compile those and put them into a tabular form. So let's go ahead and run that. And you'll see here, this is going to be a pretty useful, helps you understand the context of the different words that will be used and how frequently are they used by each of the categories within Brown. So you can see here the different categories that there are, and then some of the words that are in the news one. So you can see here it forms this nice tabular form, and you can see how many times it's used and at what ratio they're being used, if you want to calculate that. So you can see here some, like the word will is very popular in news, for example. It's the most popular out of all the different texts, and as well as it's the most popular within this text. So that's interesting. Things like humor, you can see, are pretty low across the board for these words. Things like can is pretty popular with hobby texts. And it's actually the most popular, and it is definitely most popular across the various categories. So that's useful. A great way of analyzing and utilizing lexica resources. The next one we're going to cover is going to be plotting the uses of words within the, I believe this is the inaugural speeches. So you can see here we're going to be importing the inaugural speeches, and then we're going to be using this conditional frequency, and it's conditional based off of the uses of the word America and citizen. And you can see here we've lowercase this word as well, and then we're going to plot them, and it's basically going to show how many times citizen and America is used across the number of different inaugural speeches up to 2009. So which is, I think, Obama's first inaugural speech. So you can see here, and goes back a pretty fair distance. So it just showed up on my other screen here. So you can see here how America and citizen are used across the years, all the way up to 1789, which is pretty good. A pretty in-depth one. You can see here they didn't use the word citizen a lot in 1977, whoever his inaugural speech that was, but you can see also he wasn't used a couple of times, but you can see it was used a lot in the 1841, which is quite a while ago. So you can see interesting pattern, good to leverage that. So let's comment that out and move on to the next area. The next area is removing stop words. So if you're not familiar with stop words, actually, let's do this. Maybe I can just print these stop words just so we can see them. Stop words are things like the, that don't really, as I said in my previous video, don't really add any value from understanding the actual context of the text. So you can see here things like I, me, a lot of pronouns, yourself, etc. This, then, why, ma, etc., etc. So you can see a number of different stop words. So I just want to show you examples of this. So here we developed a function. It's called content fraction. So you can see here we're using that here, and then we essentially we put the list of stop words into this variable called stop words, and then we basically loop through the text and then remove the stop words and then return this new list. So what we're going to do here is we're going to print no stop word removal, so you can see what the 50 most common words are without stop words, and then once we are with stop words included, and then without stop words removed. And you can see how it's going to be useful and helpful. Okay, I have the word 7 here. Oh, must have put that. Okay, yep. So let's get rid of this one here. I forgot to remove the bottom of that comment section. And we're going to be using this freak disk, the function that we utilized last time. So that's why we're importing all these different text documents as well. So it does take a little while because it's obviously a lot to process, right? There's a huge amount of words. It has to determine the frequency of it, then export the result. So you can see here, a lot of them are going to be the, of, to, in, and, a lot of words that you can see the frequencies are quite high in this. So even removing the stop words is going to allow us to process things a lot quicker once we get rid of all the words. You can see these periods and commas are something that you're gonna have to deal with as well, that you can potentially adjust. So you can see said moved up here, MLN, VS, dash, DLSR, a lot of different ones, and obviously you can adjust and go through this and further redefine the stop words or the other words that you want to remove. But you can see how powerful of a tool it can be through this one simple example. It can really help you with your natural language processing. So let's go down to this next section, which is we're essentially using this schematic oriented dictionary of English, which similar to a thesaurus, but with richer structure. So it's going to allow us to understand the relationships between different words. So we're going to do things like print out the different lemma names, the definition, examples, and as well then print go through the lists related to cars. So again, these are good beginner tools. Natural language processing is a very complicated task, but NLTK definitely simplifies a lot of things for you. So you can see here, okay, I didn't print out this, sorry. Let's print this out. Yeah, I should print these out. That probably would help. And as well, I don't need to use this anymore, so I'm just gonna comment that out. But run a little bit quicker. As well, I could have commented some of these other ones out as well. So let's take a look here. So you can see here the different lemmas, which is for what did I put down here? I put within this car.n.01. You'll see things like car, auto, automobile, machine, motor car. The definition: a motor vehicle with 4 wheels, usually propelled by an internal combustion engine. Okay, Tesla would probably say something different. Then example here would be he needs a car to get to work. So you can see an example from that they provide within this SYN set. And then as well, within each of these sin sets, you can see here they'll print out the different lemma names associated with them. So you can see a lot of them are very familiar. Obviously, this first one is very similar, is exactly the same as the other one. And then but you'll see some other things like other alternative meanings potentially, like car, railway car, railroad car. I don't know what that is. Elevator car, cable car. So lots of different examples. So that's examples of how you can access different corpora and as well take advantage of different lexica tools to enhance your natural language processing. So I'm going to leave that there. If you have any questions or comments, feel free to leave it in the comment section below, and I look forward to speaking to you next time. Thank you.